My name is Chao Yulu. I am a postdoc at Tsinghua University. Well, unfortunately, the authors couldn't join us, so I'll be helping them presenting this work. So hijacking domain names, particularly we're talking about from the authoritative side, has been a pretty classic problem in the DNS for a long time. Several attack methods have been discovered that divert queries to false authoritatives of domains or inject rogue resource records into their zones. So this work reports another form of covert domain hijacking, which builds over a practical choice that entities, like DNS hosting platforms, may share their infrastructure. So by exploiting those with weaker security practices, false resource records can then be injected even into some popular domains. So an executive summary, this work finds that it is now prevalent for entities to have shared authoritative infrastructure, like behind two different DNS hosting platforms, a same group of servers might be serving their domains. And on top of this, we propose the XD-auth attack, a covert threat model that exploits the platforms and take over even popular domain names. So a brief callback on the DNS, or the domain name system. It primarily translates domain names to IP addresses and serves as the start of almost every internet activity, like web browsing, email, and more. And when a domain needs to be resolved, our client sends a query to a recursive resolver, which in turn queries different levels of authoritative servers for the final answer, like root servers, top-level domains, and second-level domains, and beyond. And for second-level domains registered by regular users like us, a popular choice right now is to delegate their authoritative services to DNS hosting platforms. So zone files will be loaded onto these platforms, and they'll appoint some authoritative servers for our domains. And when talking about domain hijacking, specifically from the authoritative side here, it's about redirecting domains to false locations, thereby hijacking or altering their authoritative resource records. So we have seen dozens of methods under this category by taking over dangling DNS records of name servers, domain name squatting, or exploiting registrar management flaws to gain control over their authoritative servers. And some mitigation has been proposed and adopted so far. For example, host platforms may perform validity checks against NS records of domains delegated to them to prevent any stale ones. And they may also check ownerships of domains before serving as their authoritative. And also for domains of large enterprises like Google and BBC, though they're delegated onto some hosting platforms, their authoritative server names stays under their apex domain rather than under the platform domain, which reduces chances of name server takeover. But we show in this work that even with these measures deployed, hijacking domains from their authoritative is still possible. The XD-auth attack exploits an emergent practical choice called shared infrastructure. So what shared DNS infrastructure means is that though under different companies and different apex domains, authoritative servers behind different entities might be the same. Like in this example, two separate domain names are delegated to authoritative servers of two different DNS hosting platforms, and we call them entity A and entity B here. And however, the authoritative name servers like ns1.entitya.com and ns1.entitb.com point actually to the same IP address. That means entity A and entity B are actually sharing. And typically in practice, there is loose isolation between the servers of the entities. And in this example again, authoritative servers under entity B will be able to provide answers to domains delegated to entity A because they're essentially the same pool of servers behind. And under this setting, when either of them has weak security, then all domains delegated to both entities will be at risk. So in this example, suppose there is a victim.com delegated to authoritative servers under a hosting platform called secure.com. And one day, the victim decides to cancel its DNS service on this platform, causing its authoritative records to be removed. It has not been migrated elsewhere yet, so its delegation to secure.com authoritatives has not been changed yet. But what the victim does not know is that secure.com platform is sharing its authoritative servers with another platform called vulner.com. And somehow, the vulner.com has some weak security checks, allowing itself to configure data and serve domains not delegated to itself. And the attacker knows about it and configures some false resource records of this victim.com on the authoritative servers of vulner.com's platform. So normally this wouldn't hurt at all because this victim domain is not delegated to vulner.com at all, so queries for it won't arrive at the name servers of vulner.com at all. But in our setting, remember, the two platforms are actually sharing their infrastructure. Under this setting, records configured through vulner.com is valid for secure.com as well. So when clients query this victim.com domain, it'll arrive at its secure.com servers, which are also vulner.com servers. And because records have been configured through this vulner.com platform, false data will be returned as a result, and thus hijacking the victim domain covertly. So to enable this threat, how may we discover two entities like DNS hosting platforms are actually sharing their authoritative service behind? So a key concept of shared authoritative servers with loose isolation like this is that they will be able to provide correct authoritative answers to domains not delegated to it. And for example, in here, this domain example2.com is not delegated to entity A, but name servers behind entity A will be able to provide its authoritative data because it shares with entity B, where example2.com is delegated. So to discover servers meeting this case, we filter around 25,000 NS records from research reports and TLD zone files. We're mostly focusing on NS records that points to DNS hosting services. And for each name server and all domains associated with it, we perform a cross-check to see whether the domains can be answered by other name servers. The algorithm is essentially of a quadratic complexity, so instead of running it through, we did a lot of filtering to reduce the size of queries, and you may refer to the paper for details. And finally, to identify whether weak entities are presenting in these shared cases. So with whois and HTTP responses, we find the platform in front of the shared name servers. For example, in front of domain control.com name servers is actually GoDaddy. And then we manually register accounts on these platforms and test if data of domains not delegated to them can be configured on them. So our results show that shared name server infrastructure is actually much more prevalent than expected among these entities. A total of 64,000 authoritative servers are sharing with others. Some large pools are even associating with dozens or even over 100 server names. And here we visualize some large groups which have shared infrastructure behind. We find some large DNS service providers are actually associated with multiple other platforms, like domain control of GoDaddy and NS1. They both have relations with some other platforms. And under the XD-auth threat model, within one group, if any provider has weak security and allows misconfiguration, then all others and domains delegated to them are actually at risk of takeover. And by digging into why platforms are actually sharing this often, we uncover 4 major scenarios. And sometimes it's basically due to a business decision, like different platforms are actually subsidiaries or have been acquired by a large company, so their servers behind are actually the same. Like when DigiCert acquired DNS Made Easy, though they're using different authoritative server names under different apexes, the pool of servers quickly became the same. And in the end, we find 12 mainstream DNS hosting providers and around 125,000 domains are at risk of takeover by XDOff, including websites of some famous brands and large enterprises. So we have disclosed this issue to the affected vendors. Until now, some DNS hosting service providers have acknowledged and fixed the issue, like NS1. And the pharmaceutical company McKesson has thanked us for a report and is currently in the process of fixing. And to mitigate this issue, we provide some suggestions for different entities, like you should check domain ownership before name server delegation. So to sum up this work, it reports a new attack called XDOff, which enables covert domain hijacking from the authoritative side. And the problem roots from a surprisingly prevalent implementation choice that different platforms may share their authoritative servers behind, and they actually have loose isolation. And as a result, if one of them has weak security, then all other platforms and domain delegated to them might be at risk. And through large-scale probing and analysis, we did uncover great potential against several large hosting providers and some popular domains. And that's it for this talk. Yeah, I should say that I'm not one of the authors of the paper, so I might not be able to answer some specific questions. And in that case, you may email to the authors directly as this address. Thank you.